Hi folks, welcome to day 2 of our extra credit unit. Today we're going to be working with the quadratic formula, which we were introduced to yesterday. Make sure that if you have not already done so, you need to be watching the day 1 video first. Otherwise, I can't give you credit for the day 2 or the test. All right, so if you're watching this and you're like, it's fine, I'll skip day 1. Actually, you can't. And they have to be done in order because otherwise they won't make sense. All right? So today we're going to be working with the quadratic formula, and we were introduced to this yesterday. And in the quadratic formula, there's a lot of different letters going on, and so yesterday all we did was identify where those letters come from, in our quadratic, right? So A is always in front of the x squared, B is always in front of the x, and C is always by itself. It's just a plain number. We did that because when working today, it's really important to know exactly what your numbers are that you're working with and exactly which one's which, because putting even a single number in the wrong place can, ruin a whole math problem. I know exactly what you were worried about, ruining a math problem today, but that's okay. So we're going to just go ahead and dive in, and I'm going to teach you as I go how to do these problems because it makes just a lot more sense to see it in action. So if we have the quadratic x squared minus 6x plus 5, all right? Now, normally that's equal to like a y, right? But remember, we are working with quadratics, and our quadratics, what we're trying to find, if you forgot, are our x-intercepts, where they cross the x-axis. So that's where y equals 0. So instead of y, we have to make sure that there's always a 0 here. If this was a number, like say instead we had like x squared minus 6x plus 4 equals like -1, right? If it equals a number, then your first step, instead of setting it equal to 0, is to make it equal to 0. So you'd have to add the 1 over in order to set it equal to 0. After you have your quadratic set equal to 0, then you identify your a, your b, and your c. So I have ax squared plus bx plus c. So my a, right, my a is lined up there, lined up my b, and lined up my c. So if we look here, we have an a value of 1. And our a value is 1 because there's no number in front of the x squared, right? Anytime that there's not a number, there's not a coefficient in front of a variable, that means that the coefficient is 1. It can't be nothing. It can't be 0, right? Because 0 times x squared, 0 times anything is just 0. So it has to be 1, because 1 times x squared or 1 times anything is just whatever you started with, right? So our a is 1. B is lined up with our -6, and C is lined up with 5. If you want to do this, it's really important that you're lining up your quadratic in standard form. Otherwise, you can't just say, oh, yep, A is lined up with the one on top and stuff like that. All right. Now that we have A, B, and C identified, we can go ahead and plug them into our formula. So we know that we're trying to find our x values where the graph crosses the x-axis. And we know that that's equal to -b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. After we identify our a, our b, and our c values, all we have to do is plug them in and evaluate. So we get x equals negative, but our b is -6. So we have -6 plus minus the square root of b squared, but remember b is -6 squared, minus 4 times a, which is 1, times c, which is 5. And that's all being divided by 2 times a, which is 1. After we have everything set in our formula, then we have to go in and follow PEMDAS to evaluate. All right. And that's a huge thing. Some of y'all are still forgetting PEMDAS. Some of you are still like adding and subtracting your -6 and your -4 before worrying about like the squared or like this multiplication. All right. So PEMDAS is honestly one of the most important things you're ever going to learn in math because it's how all math works. Until you get into like super complex higher level math, but that's not important right now. All right. So following PEMDAS, we're going to first deal with our parentheses, all right? So we have a few sets of parentheses, but most of them are actually showing multiplication, right? So here we have negative, and then a parentheses, and then a -6. This is actually -1 times -6. So that's a multiplication. We'll save that for later. Other than that, the only parentheses we really have that has something else going on that's not multiplication is this parenthesis set here, which actually has to deal with your exponents, right? So there's no parentheses we actually need to eliminate. So then our next set is to exponentiate. So if we were to exponentiate, we have our -6 squared. And if you put in your calculator -6 squared just like that, chances are it's going to give you -36 as your answer, but it's not. That's because calculators are dumb. You actually need to put in those parentheses around that -6, otherwise it reads it differently. It reads it as -6 squared, which is very different. I don't know why calculators do that, but they're just not super great in terms of like reading logic. All right. So we're left with, so we have -6 plus minus the square root. Instead of -6 squared, -6 times -6 is +36. Minus 4 times 1 times 5, all over 2 times 1. All right, so we dealt with our exponents. Now we can do that multiplication division stuff. So we have -6, that gives us +6. We have plus minus our 36. Then we have -4 times 1, which is -4. And then -4 times 5 is -20. All right? So we have -20. So we have 36 minus 20. And that's all over 2 times 1, which is 2. At this point, we can now split our x into our plus on one side and our minus on the other. So we know that x equals 6 plus the square root of 36 minus 20, and 36 minus 20 is just 16. So we have 6 plus the square root of 16 over 2. And we have 6 minus the square root of 16 over 2. All right, so those are your two x values. Because remember, we're working with quadratics, right? Which means they cross the x-axis 2 times. All right. So the square root of 16 is just 4. So we're left with 6 plus 4 over 2. And 6 minus 4 over 2. We know that 6 plus 4 is 10, so we have 10 over 2, which is just 5. And then 6 minus 4, well, that's just 2, and 2 over 2 is just 1. So your two solutions are that x equals 5 and x equals 1. Remember, you get two solutions because it crosses the x-axis in two different spots. Does that make sense? This would be like your P and your Q from intercept form, right? Like the x minus P, x minus Q stuff. These are your intercepts. All right. So that's how we find our x-intercepts, or find the zeros of our quadratic, okay? So what we did was, all right, bringing us back to the beginning, we started by identifying our A, our B, and our C, plugged them into a formula. Then from that formula, we had to follow PEMDAS in order to get our final answers. PEMDAS is going to be the most difficult part of the quadratic formula because you have to follow every single step. All right, let's go ahead and have y'all try one. Let's go ahead and have you try out So we have 4x squared minus 4x equals -1. All right, go ahead and try that out. So you should have gotten, right, hopefully you remembered to bring that -1 over, right? Make it a +1, set it equal to 0. All right, and you should have gotten that x equals 1/2. All right. There's only one answer because you end up with a square root of 0. So adding and subtracting the square root of 0 is just 0, so you just get your answer. All right, let's do one more. So we have 1/2 x squared plus x minus 10 equals 0. I know that 1/2's going to be scary for some of you. All right, so you should have gotten that x was about 3.6 and about -5.6. All right, so those are rounded, but that's what you'd roughly what you get if you rounded the same way I did, I guess. But yeah, so that's all I got for you today. It's just plug and chug with that formula. All right, so that's all you had to do today. Tomorrow we'll be working with some correlation between the number of x's or a number of answers and our graphs, what the graphs will look like in that, what that physically means. All right, so that's what you have to look forward to tomorrow. Other than that, have a great rest of your day.